This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us at greatercommons.com. So here's the scenario. You have two buildings connected via multi-mode fiber. The first building has 6 existing analog cameras, and the second building has 1 new IP camera. The equipment list that you've been given for building 1 is a Cisco SG300 28-port PoE switch that you need to install a multi-mode SFP in, which is short for short form plug, and you're going to use an Axis M7016 16-channel encoder to digitize the streams coming from those 6 existing analog cameras, and then you're going to record it all to a network video recorder. That's also going to reside in the first building. The equipment list you have for the second building is also a Cisco SG300 28-port PoE switch that you also need to install that same Cisco transceiver, transmit, receive, SFP in. And you're going to be provided a P3364 Axis IP camera. So first thing that needs to happen is you have to come up with a scheme for all this. So the switch in the first building, we're going to use an IP address of 192.168.1.1 with a mask of 255.255.255.0 Class C. And there's going to be 2 things connected to that switch in the first building. An encoder, which we're going to use 192.168.1.81, and that /24 just denotes the same thing. It's a Class C mask, 255.255.255.0. It's just a shorter way of writing it. The NVR is also going to reside in building 1, and that's going to have an IP address of 192.168.1.21. Same thing, Class C. And they're going to be connected via multi-mode fiber. And remember, we have the transceiver that's going to be here and here. And in building 2, we're going to use the second switch, which is 192.168.1.2. And again, Class C, with that camera of 192.168.1.101. Let's get started. Alright, so the first thing you need to do is get yourself connected to the switch and get the switch powered on. For me, you guys can't see it, but it's next to me. You might be able to hear it because it's super noisy. But so the first thing we need to do is get ourselves connected to the switch, which should be done already. And then we need to change our IP address so that we are on the same subnet as the default IP address that this SG300 gives itself when it powers on. So there's 2 ways you can get there. There's probably multiple ways you can get there, but this is one of the ways. Change adapter settings, and under network connections, you need to identify what NIC card you just plugged into the switch. If you have multiple NIC cards, like I do in this machine, I've emphasized what actually got connected to the switch, but I named it Offline Security Network NIC 2. And this is what's actually connected to the internet. You can be connected to 2 places at once, so long as you don't have multiple gateways set up on these NIC cards. Next thing you need to do is change the IP address of that NIC card. So go to Properties and use the following IP address. The default IP address on the SG300 series is 192.168.1.254. So we're going to give ourselves an IP address in that range, 168.1.200. And we can leave the Class C that it gave us, that's fine. No need to configure the gateway, no need to configure DNS. So first thing we're going to try is see if we can ping that IP address. So ping 192.168.1.254. And good, it's responding to us. So that means the switch is online and it's at its default IP address. So the next thing we need to do, and I'm going to back out of this presentation. Right, so we need to go to the default IP address of that switch, 192.168.1.254. And we get a login page. The default login is Cisco. And based on the firmware, it should ask you to change that password, and it does. So old password is Cisco. No, I'm not going to generate the password. Let's type in a password. we're going to disable the password strength enforcement. Let's say OK. So this is flashing save because you changed the default password on the Cisco account. So we're going to save that, and we're going to apply it to the running configuration, which is running on the switch right now, and the startup configuration, which is what runs on the switch after it reboots, well, what starts up when the switch reboots. So if you were to save it just to the running config and not the startup config, and you rebooted the switch, you'd lose what you did. So processing, that's done. Good. Now the save icon will stop flashing at us. So under the management interface, you need to change the IP address because we can't leave it at the default, right? We had in our presentation what we were going to change it to. In this case, it was 192.168.1.1 because it's the first switch in building 1. We can leave the mask alone, and we will apply this. Okay. And because we actually gave ourselves a 192.168.1.x address, we're already on the same subnet that we changed the IP address to. In this case, it makes it easy, but if we weren't, we would have to go and change our IP address settings to match the new subnet that we gave the switch. We're going to use Cisco. And the password that I set. And we're going to save this again because we changed its IP address and we need it to stay that way when we reboot these switches or when they lose power. The next thing we're going to do is check and see what the firmware version is on this switch. So firmware version is 1.3.5.58. We can check and see what the latest firmware for these switches is, and I'm going to do that right now. So I'm going to pause this. Okay, so one thing to be aware of when you're downloading firmware for these switches is that there's two different things. There's the active image, which is the firmware version the switch is running on, and that on this switch is 1.3.5.8, 1.3.5.58. But there's also boot code, and they're two different things. So if you were, we'll back out of here, but if we go to Google and you were to type in Cisco SG300 series firmware. Ideally, it brings you right to the page. This doesn't always happen, and Cisco's website in the past has been notoriously hard to navigate. So thanks, Google. All right, so what I was mentioning there, when you see the SX, so it's saying anything in the 300 series will work with this firmware, you can download this, but this is only the firmware image. You want the boot code too. And sometimes you have to dig for that. So we'll take the latest firmware, which is 14705. Yes, we know. Download. Okay, so now we have the firmware. 2 of them because I was impatient. And we are looking for the boot code. And it's right here. So this actually contains the firmware and the boot code, but we'll take both and we'll cherry pick out the boot code. Give it a second to download. Okay, so now that we have both of these files, the next step is to set up our TFTP server, extract the firmware, the .ros file, and the boot code, and get them on the switches, and I'll show you how to do that. Okay, so I have our files here, and one thing to be aware of is when you have zip files, particularly on Windows 10 and I believe on Windows 7 too, you need to go to Properties and unblock them. I already unblocked it, but it will be there and it will cause issues if you don't. So now that we've unblocked it, we're going to take out the RFB, which is the boot code, and leave that in the file. And remember, we downloaded the latest firmware, If you were to just use the firmware that came with that boot code, it's actually a little bit behind. It's 1413, and the latest is 1475. So now that we have what we need out of that zip file, I'm going to get rid of it. I use a TFTP server called TFTPD, and you can download that by going to Google TFTPD 64, and this is the link. And it looks like they updated as of January 3rd, and this is what you would download. So the standard edition, I'm on a 64-bit machine. I believe the 32-bit will work on a 64-bit machine though. So let's go back to that. So we need to run our TFTP server, and we want to see what directory it's looking in. And right now it's just looking in the directory that it resides in. So what you could do, just to make it easy, you could take the firmware and the boot code and put it inside the TFTP server. Now if we do a show dir, yep, we do have them. Good. So now you're set up to actually TFTP these files over to the switch. I believe you don't have to TFTP the firmware, but you do need to do TFTP for the boot code. So Cisco without password. If I remember it. There we go. Okay. So under administration, file management, upgrade firmware. As you can see, boot code is actually grayed out, and you have to change it to TFTP. Select boot code. Your server address, we can use 127.0.0.1. So 127.0.0.1. And I'm kind of expecting an issue here because I haven't changed any of the firewall settings on this machine. But this gives you a better example of what you're actually going to run into. So we're going to take our boot code. And again, I'm just going to show directory, boot code, RFB, copy, close, and paste. So are we running? We are running. And we should be able to hit apply. And it should go and grab unicast address. I got that backwards. We need to put our address in 192.168. Because now you're telling a switch to go to itself, and that's kind of silly. So 192.168.1 dot. What do we give ourselves? We gave ourselves, let's see, .200. Dot 200. And apply. Wow. It's the first time that I think I've ever gotten it on the first try. Cool. File upgrade will take place only after the switch has been rebooted. So we are going to reboot the switch, and I'm not going to make you wait through that process because it is long. So we're going to reboot. Device connected. We're going to check one more thing before we reboot. Firmware is 135.58. And the boot version is 135.06. So we're going to reboot. Say OK. Success. So if you're impatient like me, you can run a ping-t to the switch, which will just constantly send echo requests to the switch. And you can see here the switch wasn't up, so it was request timed out. And then as soon as the switch came back, a little bit of a delay there with that response time, but that's expected. It's doing other things. And now it's back. So it's already back up. We're going to log back in. And we're going to check our boot code, which 13506. I realized that was the same boot code that we started with, but it was still good to walk through the exercise, just to give you an idea of what to expect. So it's flashing at us, telling us to save, so we're going to do that. And then we're going to update the firmware. So upgrade, backup firmware. So then we're going to TFTP again, just to make it hard. 192.168.1.200 is my IP address, and the source file, show directory, and that's the new firmware that we put in that folder. So we're going to copy the path, leave that running, paste, Control V. So we have TFTP selected, upgrade, firmware image, apply. And you can see the progress indicator here. Okay, so once that's done uploading, you need to go to the active image and change it to the image that you just uploaded. This is what the image is going to be after you reboot the switch. So we're going to apply that, and then we're going to reboot the switch again. So reboot, okay, and I'm going to pause it so you guys don't have to watch the paint dry with me. Okay, our switch is rebooted. We're going to log back in. And we're going to check and see if the firmware is active. And it is. Excellent. Switch's firmware is upgraded. Everything's up to date. The boot code was already in the latest, but we did it anyway. And that's it for your switch, your basic switch configuration. Good job.